A firefighter bursts through the doorway of a burning building. Flames crackle overhead, smoke claws at her lungs, and every instinct screams at her to turn back. She's not reckless. She's not seeking glory. She's terrified, but she keeps going, one foot after another, deeper into the heat. And for a moment, something extraordinary happens. Fear and action exist side by side. It looks like courage. But what is courage, really? Is it the absence of fear, or is it something more strange, more fragile, more deeply human? Why do some people charge into danger while others, equally well-intentioned, freeze even when they desperately want to move? For centuries, courage has been treated as a moral virtue, a conscious act of character, a triumph of the will. The brave were honored not just for what they did, but for choosing to do it in the face of fear. Philosophers, from Aristotle to the Stoics, described courage as self-mastery, a decision to do the right thing even when the cost was high. But modern neuroscience is pulling back the curtain on something startling. Courage, it turns out, might not be purely a decision. It might be a physical process, a negotiation wired into the architecture of the brain, a biological seesaw, where fear pushes one way and action pulls the other. And in those rare moments when action wins, the result is what we call bravery. Take the story of a soldier in Afghanistan who earned a medal for dragging his wounded comrades out of a kill zone under fire. Afterward, he had no memory of it, no dramatic inner monologue, no heroic clarity, just blankness. His body had moved, his brain had dissociated. The courage he displayed didn't come from a conscious choice. It emerged from deep within the brain's survival circuitry, bypassing thought entirely. Or consider the case of a mother in Georgia who watched a child get pinned beneath a car. Without thinking, she rushed forward and somehow lifted the vehicle just enough for the child to be pulled out. A moment later, she collapsed, trembling and weeping, overwhelmed by what had just happened. She hadn't felt strong or brave. Her body had simply acted as if pulled by something ancient. These aren't stories of mind over matter. They are stories of matter itself, of neurons firing, hormones flooding, instincts overriding thought. They are stories of biology in motion, of systems in the brain built not for glory but for survival, now co-opted for something nobler. Courage, in this light, is not a rejection of fear. It is what happens when fear and purpose collide, when the amygdala flares, the prefrontal cortex strains to push forward, and the body becomes a vessel for something that neither fear nor reason can fully contain. And perhaps that's the paradox. Courage doesn't come from erasing fear, but from walking with it, not as its enemy, but as its partner. Fear is not a flaw in our design. It is one of our oldest and most vital evolutionary tools. Long before language, civilization, or even complex social structures, fear was there, hardwired into the nervous systems of early animals, sharpening their senses, speeding their reactions, and urging them to survive. The rustle in the grass, the flicker of movement in the shadows, these signals were not just noticed, they were felt, viscerally, through the rapid-fire neural alarms of what we now call the amygdala. This tiny almond-shaped cluster buried deep within the brain is one of evolution's masterpieces. It doesn't think, it doesn't reason, it reacts. In a fraction of a second, it floods the body with stress hormones, primes muscles for action, and makes the heart race. It's what has kept our species alive for hundreds of thousands of years. But if fear is ancient and automatic, the ability to act in spite of fear is something much newer and much rarer. From an evolutionary standpoint, freezing or fleeing was often the most adaptive response. Courage, in contrast, is a kind of biological rebellion. It asks the body to move toward danger rather than away. And this isn't easy. Neuroscience shows that acting courageously, that is, Choosing a purposeful response in the presence of fear requires a powerful and delicate brain mechanism. At its core is a dynamic tension between two major neural players, the amygdala, which signals fear and prepares us to withdraw, and the prefrontal cortex, the seat of planning, reasoning, and decision-making. When a person shows courage, what's happening is not the absence of fear, but a struggle in which the prefrontal cortex must inhibit the overwhelming signals coming from the amygdala. That effort, the literal physical process of fear regulation, is biologically demanding. It's not just willpower, it's neural warfare. This balancing act between fear and action has deep evolutionary roots. In early human communities, courage had a direct survival value. When a predator approached or a rival tribe attacked, someone had to hold the line. But courage wasn't about showmanship, it was about sacrifice and preservation. Those who could regulate their fear well enough to defend others or face danger became essential to group survival. And over time, their actions were remembered, imitated, and selected for. Courage then became a kind of evolutionary currency. It was not blind bravery, but calibrated risk-taking that served the tribe. The individuals who could master their instincts, not ignore them, but command them, became leaders. Courage wasn't a luxury, it was a necessity. Yet in modern culture, courage has often been misunderstood. We tend to glorify the image of the fearless hero, the unshakable warrior, the stoic firefighter, the invincible protagonist who doesn't flinch. But this romanticized vision of bravery ignores what biology teaches us. True courage isn't about suppressing fear until it disappears. It's about feeling it fully and still choosing to act. It is, fundamentally, a form of emotional regulation. The prefrontal cortex engaging in a delicate override of more primitive, reactive circuits. And here's where it gets even more compelling. This process is measurable, and it's trainable. Neuroimaging studies show that people who practice certain techniques, like mindfulness, exposure therapy, or even mental rehearsal, can strengthen the neural pathways that support courageous behavior. The circuitry of courage can be built, like a muscle. This means bravery isn't reserved for the rare or the extraordinary. It's a skill, a practice, a function of the brain that anyone, in principle, can develop. Understanding this changes everything. It means that those moments of trembling hands, dry mouth, and pounding heart are not signs of weakness. They are the biological stage on which courage is performed. And the person who moves forward anyway, not without fear, but through it, is doing something extraordinary. They are harnessing one of the most complex and powerful processes the human brain is capable of, not silencing fear, but negotiating with it. That's the essence of courage, not the absence of emotion, but the mastery of it. In 2008, a groundbreaking study conducted in Israel quietly reshaped how scientists understand one of humanity's most cherished virtues, courage. In a dim laboratory, researchers designed a controlled experiment that simulated fear without real danger. Participants were placed in an fMRI scanner, a machine that maps brain activity, and asked to perform a simple but psychologically intense task: slowly move a cursor toward a live snake confined in a transparent, motorized tank. The snake would move closer as they did, coiling, shifting, visibly alive. The fear was real. Participants were told they could stop at any time. Some pressed forward, inching closer to the reptile. Others couldn't. The scientists weren't looking to test bravery in the traditional sense. They were looking for patterns in the brain, and they found one. Those who chose to move the cursor closer to the snake, even as fear clearly surged in their bodies, showed a spike of activity in a specific and surprising region of the brain, the subgenual anterior cingulate cortex, or SGACC. This area sits deep in the brain's frontal lobe and is known to regulate emotion, particularly the balance between negative feelings like fear and the cognitive control needed to override them. In simple terms, the SGACC appeared to be the biological seat of courage. It lit up when fear was present, but action happened anyway. Courage, the study suggested, wasn't just a personality trait. It wasn't only moral strength. It was a physical phenomenon, a flash of coordinated neural activity in a very particular piece of brain tissue. The implications were enormous. If courage can be seen in a scanner, if it has a biological fingerprint, then bravery is not merely a matter of choice. It's a neurochemical event, something measurable, perhaps even something modifiable, and that opens a deeply uncomfortable question. If courage is biology, then what about cowardice? Are we wrong to judge someone who freezes, who panics, who can't bring themselves to act? If their amygdala overwhelms their SGACC, if their fear response outpaces their regulation circuitry, is that a moral failing, or just a different neurological baseline? For centuries, we've told stories that divide people into heroes and cowards, but neuroscience complicates that narrative. What if the soldier who ran toward gunfire simply had a more robust SGACC? What if the person who couldn't scream during an assault wasn't weak, but neurobiologically overwhelmed? This dilemma strikes at the heart of how we reward or shame behavior. If courage is not fully a choice, if it arises from brain architecture shaped by genetics, upbringing, trauma, and neurochemistry, then how should society treat acts of bravery? Should we continue to celebrate the courageous as moral examples, or do we begin to see them more like gifted athletes, people born with or trained into a rare configuration of neural resilience? And if that's the case, could courage someday be measured in brain scans before a person ever faces danger? Could it be enhanced with medication? Could we train soldiers, firefighters, or first responders to strengthen their SGACC the way a weightlifter trains a muscle? These questions aren't science fiction. They're fast becoming science policy. Military organizations are already funding research into enhancing fear tolerance. VR therapy is being used to rewire trauma responses in veterans. Neurofeedback programs are being tested to strengthen emotional control under stress. We are entering an era where courage may not just be honored, it may be engineered. But in this emerging world, a profound ethical tension remains. If bravery can be manufactured, is it still meaningful? If we reduce courage to circuitry, to blood flow and brain chemistry, do we risk stripping it of its moral power? Or does this new knowledge give us a deeper, more compassionate understanding of human limitation? The old stories taught us that courage was a virtue of the soul. Neuroscience suggests it is also a property of the brain, and that discovery, powerful, promising, and unsettling, asks us to rethink what it means to be brave, not just in how we act, but in how we understand those who can't. When we think of heroism, we often imagine a moment, a split second when someone runs toward danger, stands up against injustice, or puts their own safety on the line for others. But beneath these extraordinary acts lies an intricate cascade of physiological events that unfold in real time within the body. When a person engages in a courageous act, the entire nervous system lights up. Adrenaline floods the bloodstream, sharpening focus and accelerating reflexes. Heart rate surges, sometimes doubling in seconds. Blood vessels constrict in the skin to preserve blood for the vital organs. Cortisol, the primary stress hormone, often spikes, but curiously, in some individuals, it drops. This pattern is not random. Studies of combat veterans, emergency responders, and frontline healthcare workers during crises have revealed that in moments of courage, the body doesn't simply react with panic. It often shifts into a strange state of calm urgency, what some have called the flow of fear. Time seems to slow. Movements become precise. The body, in its own way, braces for moral impact. Consider the combat medic treating wounds under enemy fire, or the ICU nurse during the peak of the COVID-19 pandemic holding a stranger's hand as they pass, knowing full well the virus could be inhaled with every breath, or the whistleblower sitting alone in front of a congressional hearing, risking a career, a reputation, a life's work. These aren't just stories of valor, they're biological marvels, the body pushing against its own alarms, sustaining clarity in chaos. And yet, what makes these acts even more remarkable is not just the physiology of the moment, but what follows. Because courage, as biology shows, doesn't always leave quietly. Sometimes, it leaves scars. The village of Le Chambon-sur-Lignon, in Nazi-occupied France, offers one of the most powerful counterexamples to our individualized concept of heroism. Here, in a remote Protestant community, an entire population quietly defied the Gestapo by hiding Jewish families, forging documents, and smuggling people to safety. They did this for years, knowing that discovery meant imprisonment or death. And yet, when asked why, many villagers simply said it was the right thing to do. They didn't feel heroic, they felt human. But historians and psychologists who've studied the village found something fascinating. Courage had become normalized. Children grew up seeing acts of protection and resistance as part of everyday life. Social courage, it turns out, is contagious. When the people around us act bravely, the brain begins to code that behavior as expected. The neural friction between fear and action becomes quieter. Courage, once rare, becomes routine. This is where social neuroscience adds a vital dimension. The human brain is profoundly wired for imitation. Mirror neurons, cells that fire both when we act and when we observe someone else act, allow us to internalize the behavior of others as if it were our own. Oxytocin, the so-called bonding hormone, rises when we feel part of a trusted group. Together, these systems create what could be called shared courage. In groups bound by purpose, whether soldiers, rescue teams, protest movements, or communities in crisis, bravery spreads. When one person steps forward, others follow, not because their fear vanishes, but because their brain recalibrates what is possible. Fear is infectious, but so is courage. Yet not all acts of bravery end with medals or relief. Some leave behind a quieter legacy, trauma. When the biological systems that enable courage are pushed too far, too often, or without resolution, they begin to fracture. This is the tragedy of PTSD. A veteran may have survived multiple tours, pulling comrades from burning vehicles, witnessing death repeatedly, but the toll on the nervous system accumulates. Flashbacks, nightmares, emotional numbness, hypervigilance. These are not signs of weakness. They are the brain's injured circuitry struggling to regulate itself after too much fear, too long without a return to safety. And with trauma comes guilt. Many survivors of courageous acts report an emotional contradiction. Why did I survive when others didn't? Why couldn't I do more? These are not logical questions. They are biological echoes. The mind trying to reconcile action with outcome. Courage, then, is not always triumphant. It can be costly, quietly devastating. The very systems that allow us to override fear can break under sustained pressure. Just as bones fracture under too much weight, the brain, too, has its limits. Yet understanding this, acknowledging that courage has a biological cost, doesn't diminish the bravery of those who act. It deepens it. It reminds us that heroism is not just a shining moment. Sometimes it's what happens after, the long silence, the shaken hands, the years of sleepless nights. And still, many would do it again. In the end, the physiology of courage is not simply a matter of strength. It is a complex human balancing act between chemistry and conviction, between instinct and choice, between what the body fears and what the heart insists on doing anyway. In the hidden corners of modern military science, a quiet revolution is unfolding, one that may fundamentally change how we understand bravery. Neuroscientists working with defense agencies have begun testing methods to engineer courage directly into the brain. In classified and experimental programs, researchers are exploring how to dampen fear responses in soldiers before they ever reach the battlefield. One technique involves neuromodulation, stimulating specific regions of the brain, such as the amygdala or prefrontal cortex, to regulate fear in real time. In some trials, soldiers are fitted with implantable devices that detect spikes in stress and deliver electrical pulses designed to reduce panic before it spirals. The aim is simple: create soldiers who can remain calm and act decisively under extreme pressure. There are also pharmacological methods. Beta blockers, like propranolol, originally developed to treat high blood pressure, are now being explored for their ability to suppress the physiological symptoms of fear. Before high-risk missions, some operatives are administered these drugs to keep their hands steady, their hearts slow, their minds sharp. The fear doesn't disappear, but its grip loosens. DARPA, the U.S. Defense Advanced Research Projects Agency, has funded multiple lines of inquiry into emotionally adaptive cognition, including the idea of optimizing courage like one would enhance vision with night goggles or speed with exoskeletons. But here the story takes a turn, one that strikes at the philosophical heart of what it means to be brave. If we can design courage, is it still courage? If a soldier feels no fear because a drug suppresses it, does their actions still count as brave? Or is bravery, by definition, tied to the presence of fear and the decision to move through it? These questions aren't just theoretical. They are already confronting ethicists, commanders, and scientists who must grapple with the consequences of reducing courage to a chemical switch, and the questions ripple outward. If we normalize pharmacological or neurological enhancements to make people better at courage, what's next? Should doctors take propranolol before high surgeries? Should firefighters be implanted with fear-dampening devices? Should children one day be trained, not just in moral reasoning, but in neurobiological conditioning to act in crisis? As with steroids in sports or stimulants in academics, the risk isn't just that we change what people can do, it's that we change what those actions mean. But then comes the deeper realization: courage was never a fixed trait to begin with. It's not something a person simply has or doesn't have. It's a biological process, unfolding moment by moment, shaped by context, chemistry, experience, and connection. Most acts of bravery are not grand or cinematic. They're quiet, often unconscious, often uncredited. A nurse holding the hand of a dying patient, a teenager stepping in to stop a fight, a single mother confronting a courtroom for her child. These people may not feel brave, but their biology, their bodies, their brains choose action over paralysis, sometimes without their permission. And in many cases, courage doesn't come from within. It's borrowed from the trust we place in someone beside us, from the love we feel for someone we want to protect, from the presence of others who normalize action over hesitation. Mirror neurons fire, oxytocin flows, the SGACC ignites, and suddenly a frightened body becomes a brave one, not because fear vanished, but because something more important stepped in to carry it. So maybe the future isn't about engineering courage in isolation, like programming a machine. Maybe it's about understanding how deeply embedded it already is in the relationships and stories we carry. Courage isn't the absence of fear, and it isn't the triumph of will. It's something even more human, the biology of care, choosing again and again to act despite the danger, because something or someone matters more. Today, neuroscience paints a much more nuanced picture of courage. not as a singular trait or mysterious force, but as a dynamic interplay between multiple brain systems working together under pressure. At its core lies the emotional brain, anchored by the amygdala, which detects danger and floods the body with fear. Opposing that urgency is the prefrontal cortex, the rational brain, which evaluates consequences, holds long-term goals, and attempts to suppress the panic. And between them, often overlooked but increasingly vital, is the social brain, a network of mirror neurons, limbic structures, and hormonal systems that respond to the presence of others. Courage arises not from the silencing of fear, but from this coordinated negotiation between emotion, reason, and relationship. It is a moment of internal consensus, where fear is acknowledged but not obeyed. Crucially, neuroscience shows that this process can be shaped. Studies have found that people who meditate regularly, especially those who practice mindfulness, show increased connectivity between the prefrontal cortex and the amygdala. In essence, their brains become better at recognizing fear without being ruled by it. Similarly, trauma healing therapies like EMDR, eye movement, desensitization, and reprocessing help rewire fear pathways, allowing people to confront one's unbearable memories or threats with a renewed sense of calm. Social support has also been shown to buffer fear responses. Even the presence of a trusted friend during a stressful event reduces amygdala activity and enhances prefrontal control. These findings reinforce a profound truth. Courage is not born in isolation. It is supported, trained, and cultivated. This idea is not just theoretical. In practice, we see it in the methods used to train those who face danger regularly. Firefighters, for instance, don't simply learn how to handle hoses and axes. They are repeatedly exposed to high-stress simulations that force their bodies to respond to chaos until fear becomes familiar and manageable. Soldiers undergo similar conditioning, not to erase fear, but to move through it with increasing control. Exposure therapy, long used in psychology, uses the same logic, gradually increasing the intensity of a feared experience until the brain rewires its default response. These repetitions matter. The more often a person acts bravely, the more their neural circuits adapt to expect that action. It's a form of biological resilience, not just mentally toughening up, but physically rewiring how the brain responds to fear. And yet, perhaps the most important insight of all is this: courage is not reserved for battlefields or burning buildings. It exists in the everyday, in quiet acts that often go unseen but are no less biologically real. When a child raises their hand in a classroom, risking embarrassment, their amygdala activates just as surely as a soldier's. When someone comes out to their family, unsure of how they'll be received, their brain undergoes the same tug-of-war between fear and expression. When a woman gathers the strength to leave an abusive relationship, it is not simply a decision. It is an act of physiological bravery, a triumph of regulated fear over paralyzing danger. These moments may not make headlines, but they are, powered by the same deep biological machinery that governs acts of heroism. What this means, scientifically and personally, is radical. Courage is accessible. It is not the property of the fearless, but the capacity of the human brain. It is a skill that can be nurtured, a response that can be trained, and a force that can rise even in those who feel weakest. The circuitry of bravery is already inside us, waiting, not for perfection, but for practice. And the more we understand this, the more we can build a culture that recognizes and supports courage in all its forms, from the battlefield to the hospital ward, from the protest line to the quiet courage of survival. In the end, to be courageous is not to be without fear. It is to become fluent in fear's language and still find the strength to speak. The sky is grey and low with mist, as an elderly man stands alone in a quiet cemetery. Rain taps gently on his coat. Before him, a simple stone bears the name of a friend, a man who once, in the chaos of a rising flood, gave his life to save others. For years, the old man visited this grave burdened by guilt that he had survived, that he hadn't been the one to act, that he couldn't understand what made his friend so brave. But today, he cries, not from guilt, but from awe, because after a lifetime of wondering, he finally understands. His friend was not fearless, he was terrified. But in that moment, something in him, something made not of legend, but of biology and love, moved anyway. This was not superhuman bravery, it was deeply human, a fragile, trembling act, born from the same circuits we all carry, the pounding heart, the screaming amygdala, the storm of cortisol. And yet, within that storm, something rose, not to erase the fear, but to carry it. The man weeps because he sees now what he couldn't see before. His friend didn't act because he was built differently. He acted because, in that flicker of time, the weight of love became heavier than the pull of fear. And his biology, his cells, his brain, his body followed. Maybe courage isn't about running into fire or charging into battle. Maybe it's about standing still, heart racing, lungs tightening, the body screaming to flee, and choosing to act anyway. Not because you don't feel fear, but because something in you, however briefly, chooses to love more than fear. That choice might be unconscious. It might come from trust, from memory, from the presence of someone you cannot bear to lose. But it is real, it is measurable, and it is courageous. The truth is, courage is not always loud. It does not always come with applause. It does not always make the news. Often, it lives quietly, in whispered decisions, trembling steps, and unseen sacrifices. It lives in a mother walking into a courtroom, a teenager speaking up, a nurse walking into yet another shift. And it lives in the silent space between heartbeat and breath, where the body pauses, listens, and chooses to rise. That is courage. Not the absence of fear, but the presence of something greater. Not perfection, but persistence. Not heroism as myth, but bravery as biology, messy, human, and breathtakingly real.